This is a reciprocating compressor skid. From left to right, the control panel, the driver, the motor or engine, the crankcase holding the crankshaft and connecting rod, the cylinder with its suction and discharge valves, then the intercooler and scrubber on the discharge side, below and around the cylinder. Two support systems run continuously, the lube oil system in amber, and the cooling water system in teal. We will start the skid step by step. Before the driver ever turns, the lube oil pump starts on its own and builds oil pressure. Oil is pushed through the filter and cooler, then out to the crankshaft bearings, the crosshead, and the cylinder force feed lubricator. This pre-lube step coats every moving part in oil before there is any motion, so nothing runs dry at startup. Next, the cooling water pump starts. Water is circulated through the cylinder jacket, around the intercooler, and out to the cooler or radiator, then back to the pump. This water will carry away the heat that compression generates, so it needs to be flowing before the machine is allowed to load up. The control panel now checks its permissives. Oil pressure is confirmed healthy, cooling water flow is confirmed, valves are lined up correctly, and no safety trips are active. Only once every condition is satisfied does the panel issue a start permit to the driver. With permission granted, the driver, the motor or engine, starts turning. To reduce the starting load, unloading devices hold the suction valves open or bypass gas, so the compressor spins up with almost no resistance before gas loading begins. The driver turns the crankshaft through a coupling inside the crankcase. The crankshaft rotating motion is converted by the connecting rod into the back and forth, straight line motion of the crosshead and piston rod. This is the heart of the reciprocating compressor. Rotary motion in, reciprocating motion out. As the piston pulls back inside the cylinder, pressure inside drops below the pressure in the suction line. This pressure difference pushes the suction valve open automatically, and gas flows in from the suction scrubber to fill the growing cylinder volume. The discharge valve stays firmly shut. The crankshaft continues turning, and now the piston moves forward again. As soon as it starts moving, the suction valve closes. With both valves shut, the trapped gas has nowhere to go. So as the piston advances, the gas is squeezed into a smaller volume and its pressure climbs. Once the gas pressure inside the cylinder rises above the pressure in the discharge line, it pushes the discharge valve open by itself, and the compressed gas is pushed out toward the intercooler. The suction valve remains closed throughout this stroke, then the cycle begins again. The hot, compressed gas leaving the cylinder passes through the intercooler, where cooling water pulls the heat of compression back out. It then enters the discharge scrubber, where any liquid that condenses out is separated and drained, so only dry gas continues onward to the next stage or to the pipeline. While the machine runs, the lube oil system never stops. Oil is continuously pumped, filtered, and cooled, then delivered to the crankshaft bearings and crosshead under pressure, and metered by the force feed lubricator to the cylinder walls and piston packing, before draining back to the sump to be used again. The cooling water system also runs continuously. Water flows through the cylinder jacket and the intercooler jacket, absorbing the heat produced by compression, then travels to the cooler or radiator to release that heat, before returning to the pump to make the loop again. With everything now established, watch it run as one system. The crankshaft turns steadily, the piston reciprocates, the suction and discharge valves open and shut automatically once per evolution. Gas is drawn in, compressed, and pushed out to be cooled, while lube oil and cooling water circulate underneath it all, continuously, keeping every part fed and cool. To shut down, the compressor is first unloaded, then the driver is stopped and the crankshaft coasts to a stop. The lube oil and cooling water pumps are kept running for a short cool down period afterward, to carry residual heat away from the cylinder and bearings, before they too are switched off.